Yesterday we did the regression for this. We found the amplitude, period, phase shift, and midline. Now I want us to look at what some of these, like what does this mean in terms of the problem that we're talking about. So just to review the context of this problem, we had each month, we had put in each month as like January is 1, February is 2, and so on. And we had the hours of daylight. Okay, so I'm actually going to ask you these questions out of order. Let's do number 3 first. I need to go back and change these notes so it's first. The midline is at 12.116. In terms of daylight hours in the month, what does that mean? What is, it might not have anything to do with month, it might not have anything to do with daylight hours, but what, in terms of the context of the problem, what does 12.116 mean? It is your average amount of daylight. So 12.116 is your average amount of daylight. Okay, so the midline is usually, it's going to be the average of whatever your Y value is because it's right there in the middle. So if we look at all of the months together, average amount of daylight is 12.116 or close to it there. Okay, so then let's go back up to number 1. So the amplitude is 1.598. What does this mean in context of the problem? Savannah? Okay, good. So month with most daylight hours is 1.598 hours more than the average, which is 12.116 hours. That's one way you could say this. You also could say sort of the opposite. You could say the month with the least daylight hours would be 1.58 hours less than the average. You could also say something else like the amount of daylight hours varies up to 1.589 hours more or less than the average. But you need to say something about how that tells you how far away your maximums and minimums are from the average or the midline there. Okay. There for a minute, whenever Savannah was saying that, she was making me nervous because she said the month with the most daylight hours is 1.598. And so she was making me nervous because a lot of times students do look at amplitude like it's your highest point. Those problems that we were doing yesterday, the one on the front side of the page, the amplitude was the highest point because our midline was 0. But amplitude is only the highest point whenever your midline is 0. If your midline is anything else, it's not your highest point. It's how much you vary from the midline. So once she said more than the average, I felt much better. But she was making me nervous there for a minute. Okay. Number 2, the period is 12.27. What does this mean within context of the problem? Okay, so the pattern repeats every 12.27 months. And we talked about how yesterday it really should probably be exactly 12, but whenever you're looking at something like this and you have created this from the data, there's going to be a little bit of variation there because especially, just based on the weather, if you have had like an exceptionally cloudy month, that might make it the daylight hours go down just a little bit or something like that. All right, then the very last one is phase shift. And phase shift, I think, is a little hard to think about with these. The answer for phase shift is basically just always to get this to line up. Because, let's see, we use the sine function because our calculator will only do sine functions. It does not do cosine functions when it's doing a regression. So, sine functions, whenever we look at a sine function, it begins at 0, 0, and does this. So, if we're looking at 0, we're talking about the very beginning, switch from December to January right there. So, we're in the middle of winter. Is that whenever is the middle of winter whenever our daylight hours are the same as our nighttime hours? It is not. That's on in the spring, right? So, what they've got to do is they've got to shift this over. In this case, it's a shift of 3.13 months to the right, and then that puts it where there in December we've got more of the, we've got more of the low point. So your answer for phase shift is pretty much just always to get the data to line up. Phase shift doesn't have as much of an application as the other three. But it's necessary or you'll be way off on your months. Okay, questions? On our quiz tomorrow, I think your quiz tomorrow, you'll have, I think it's 14 questions just like the practice quiz on the calculator inactive part, and it's pretty much just like the practice quiz, so pay close attention to that. Then on the calculator active part, you're going to have 5 questions added to that. That will be calculator active questions. One of those calculator active questions is going to be, I will give you some data, and you will find the regression for me. And you'll have to tell me what your A and B and C values are for that. So that, you're pretty much just typing it into the calculator and getting the answers. Then after that, I'm going to ask you questions, but I'm going to go ahead and give you the equation. And I'm doing that because if you get the wrong, like if I gave you the data and you got the wrong equation and then had to use that to answer the next several questions, then if you miss the equation, you've missed everything after that. So rather than like using one set of data to ask all the questions, what I'll do is there'll be one where you have to do the regression because I want to make sure you know how to do that on the calculator. But after that, your question, let's see, will look more like, let's skip. Oh, hold on. Oh, it'll be more like, no, good gracious. I don't have one on here. Well, we'll just do this right here. So, if you have these filled in, is yours filled in there where it says like 11.837? I copied the wrong ones whenever I did this. So I didn't mean to do that, but you have all the answers already. But it'll be more like what we're going to do for here. I'm not going to go to example 2 and do, this all came from page 391 in your book. There's a table there for number 6. When you do the regression, you will get this answer right here. And let's see, I am going to look there so I can remember the situation to just tell you about. So for that problem, it is months and temperatures. So the table, which I'm not going to copy down here, but it is the months, and I believe it's average temperatures for that month. And this is in Seattle, Washington. So if you see numbers seeming lower than you think they should be, we're not in the same part of the country as it is here. So if you find this equation, then from that equation, on the quiz, what I'll do is I will give you the equation, and then I'll ask you a question like B. What is the amplitude of your model? All right, or I might say, instead, what is the, or how much, I'll tell you, I'll say, how much does the temperature vary from the average temperature, or something like that. So for this, amplitude is pretty easy to find, and you already have the answers, which is not good there, but you have them. So amplitude, of course, comes from this part right here. So amplitude would be 11.837 degrees. Now, if you look at the, let's not worry about this. I don't like doing this part. We're not going to do that. From the table, if you found like the difference between the highest and the lowest and divide it by 2, you could see what maybe it should be, but we're just going to go with the equation for this. For DF here, because I obviously not look over these notes very well, what is the midline of this function? The midline comes from right here. That's y equals 53.355. And that is your average temperature. So here's the same equation here. Now, this question is one I'm pretty sure that you're going to see tomorrow. Okay, so according to the model, what is the highest temperature or the lowest temperature? So I will give you an equation that represents some situation. It might be month and temperature. It might be the height of the tide. It might be, who knows, some sort of situation that repeats itself. So, gosh, I wish the answers weren't here so you could think about this a little bit better. But 53.355 is my average. So if I want to know the highest points, then I just have to take the amplitude and add it to the average. All right. So if I take the midline and add the amplitude, it gives me the highest possible value. So that would be that 65.192. In a similar manner, if I want to know the lowest, I would take the amplitude and I would take the midline and I would subtract the amplitude. And that would give me the lowest possible value in this case. So in this case, the highest average temperature should be 65. The lowest average temperature should be 41.51. Okay. If I've already got the answer there, the period is 11.341 months. Raise your hand if you can tell me how to get that number. Okay, Emily? Good. 2 pi over 0.554, and that is going to give you that number. So that tells me the pattern should repeat every 11.341 months. Now, just based on your knowledge of the seasons, what should it be? It should be 12 months, right? But sometimes you have an abnormally warm year or an abnormally cooler year, or the patterns don't really end up the same. So when you're figuring this out from data, it might be shorter than it should be or longer than it should be. But if you were to look at 100 years or 200 years or 1,000 years, if it were possible, it'd get closer to being exactly 12 there. Okay, so this last thing, I am going to grab the calculator here to show what you'll do for that. There are 2 ways to do this last part. According to your model, anytime you see that, according to your model, it means the equation. It means do not look at the table. So if you had a table, don't go to the table and tell me what the value was for July, because I know that you know how to do that. I want to know, according to this equation, how much, or according to the equation, what should the answer be? So July, what number would I plug in for July? 7. So I'm going to say, I can just go to the main screen, 11, and tomorrow you will. 7 sine of 0.554 x minus 2.450 plus 53.355. when I'm getting something way off from what I have here. So for these problems, you need to be in radian mode. It makes a difference whether you're in degree or radian mode. So I'm going to go back to radian mode. And then if I type the same thing in again. Oh gosh, it's worse. What did I do wrong? Oh, I typed in an X instead of typing in 7. So I'm pretty sure it needs to be in radian mode, but I better go check that. I might be wrong. Who knows what X is thinking X is? Okay, there we go. If I had it back in degree mode, I would still get the wrong answer. Let's see, I think. Yeah, so for degree mode, I'd have that 53.6, whatever. But you want to be in radian mode for this. Okay, so we get 65.07. You don't have the table pulled up, but if you look at the table, it was actually 65. Sometimes it's not the actual number you see on the table. Sometimes it might be like you get 62, and it really should have been 65. That's because our line of best fit doesn't always hit every point perfectly there. Okay, questions? All right, let's look at this last one here. I'm going to show you a couple ways to do this last one. You will see one similar to this tomorrow, although I will tell you it's going to be a Ferris wheel instead of the tides, but what you do is going to be similar. And it will ask you to write the equation. So it will be multiple choice. The depth of the water in the sound at high tide is 14 meters. The depth of the water in the sound at low tide is 5 meters. Last high tide occurred at midnight. The next high tide will occur at 11:50 a.m. And notice that is not 11.5 because 11.5 would be 11:30. 11:50 is 11.83333333. How do you get, like if I didn't tell you how to do that? We know that like 11.5 would be 11:30, right? So 50 out of 60 is what we're looking at there. So if you do 50 divided by 60, because there's not 100 minutes an hour, there's only 60. So you'll get 0.83333. So whenever you won't have to on the quiz tomorrow, but we might see some other times where we might have to do this, do 50 divided by the number of minutes, which is 60. Don't end up, I had one little girl one time, bless her heart. She came in and she told me, Miss Hyatt, are there 60 seconds in a minute and 60 minutes in an hour? She's in ninth grade. I said, yes, that is true. She said, somebody told me that on the bus and I thought they were lying. And I thought, oh my, bless your heart. It's been a long time. I really can't even remember her name. I remember that. I remember what she looks like. I wouldn't tell you her name if I didn't know what it was, but I think I might remember it. I don't remember her last name, but anyway, needless to say, she was not my most successful math student I've ever had. But when she said that, I thought, oh, bless your heart, honey, if you only knew how bad that was. She said that. Like, no, they weren't lying. They were right. So, I wonder what that probably third grader on the bus that told her that was thinking about her. Bless her heart. So here we have, we don't have to necessarily do a graph here, but sometimes it might be helpful. So if we just sort of sketch a graph, the lowest tide would be right here at 5, and the highest tide would be up here at 14. And it tells us the last high tide occurred at midnight. So, and midnight is at t equals 0. So high tide was at midnight. And then the next high tide occurs at 11:50 a.m. So 11.83 repeating. Here's our next high tide. And so if we're kind of thinking halfway between here is when we're going to have our low tide, and your graph will look like this. That's not the prettiest graph, but that gives us a little bit to work with. So the first way to write this equation is just to do like we've been doing everything by hand. You're just going to need your calculator because your numbers aren't perfect. So, so if my high tide is 14 and my low tide is 5, the midline is halfway between that. What is the number halfway between 5 and 14? Not an easy one to calculate up in your head. It's 9.5. All right, and if you're not sure about how to do it, just find the average of the two numbers. So 14 plus 5 divided by 2. Just add them together, divide by 2. So you get 19 over 2, which is 9.5. So the midline is at 9.5. So that means y equals, which function should I use here, sine or cosine? Cosine is going to be a lot easier because this starts at a maximum and so does cosine. So I won't have to phase shift if I use cosine. So I'm going to put cosine and I'll have something in here and we'll have plus 9.5 out here on the end. Okay? So if this right here is 9.5, what's the amplitude? How far above or below do we go? 4.5. 4.5. So our amplitude would be 4.5, because if we do 14 minus our 9.5, we'll get 4.5 there. So both of those, not too hard to figure out. A little bit confusing if you're trying to do that stuff in your head, but not too bad. Then we don't have to do a phase shift on this, which is good, but we do have to adjust the period. So I'm going to put in right here, we've got b times x. So to find the period, we would do 2 pi divided by b, right? And that would give me the period. And what is the period for this function? 11.83 repeating. So 11.83 repeating. So to solve that, I would multiply both sides by b to get 2 pi equals 11.83 repeating b. And I divide by that 11.83 repeating. And so 2 pi divided by, when you have to do repeating decimals in your calculator, just put a bunch of 3's and it'll be close enough. It'll put that many, it's going to be past the point where you're going to round it anyway. So we get, keep at least 3 decimal places for me here, we get 0.531. So y equals 4.5 cosine of what did I just say? 531. So really for that problem, we did that problem more or less by hand. We just had to have our calculator because our numbers were big decimals, right? But we more or less did that problem by hand. Let me show you another way. I think you can do it, but I need to check because sometimes the calculator can't handle it. The other way I could do this is I know the coordinates of this point right here would be at, let's see, that point right there are at 0, 14. The coordinates of this point right here, how am I going to find that y, the x coordinate? 11.83 divided by 2 is going to give us 5.916 repeating. So this would be 5.916 repeating, and the y coordinate is 5. And then here, this point is 11.83 repeating and 14. So I think it'll work if I do this. Let's check. So we could, since we've got, you have to have at least 3 points. And sometimes if you don't have the best 3 points, it still won't work. But let's see if we can get this to work. We can go to Stats. We can go to Edit. We can clear out whatever is there because second period has been doing regression stuff too. So that first point is 0, 14. The next one is 5.916 repeating, so put lots of 6s, and 5. And then the next one is 11.83 repeating, and 14. So I should have tried this before I told you it was another work. Let's see another way that will work. Let's see if it will work. So now we can do a regression with those points. So if we go Stat, over to Calc, C, and Enter. I should have tried it first. Sometimes, I don't know, I can't really figure out exactly why the calculator will do this sometimes and will not at other times, because I've done a problem like this where it would work. The one that I had put on the quiz had some problems, but then when I changed it, it would work. So I don't know why it won't work for some problems, but it doesn't. Could try it, but it does not work there. All right, so questions. All right, so basically I'm going to give you guys some time, a little bit of time to work with this today because we don't all have graphing calculators, so we can't all do this at home. So we are going to do this assignment from page 391. So 7, 8, 10, 11, 13, 15. And, oh, I need to add one more. We're going to do 16, but for 16, they make the problem pretty difficult. So, way too difficult. So I'm going to give you some information that will make it much better. So for number 16, it's giving you months and number of hours of daylight. But they don't give you the number of hours of daylight. They give you sunrise and sunsets, which means you've got to figure out how many hours of daylight that was for all 12 months, which you should be able to do, but I also don't want you to spend 30 minutes doing that. So for number 16, I still want you to do that problem, but I'm going to write down the months and the amount of daylight. So amount of daylight. So maybe go ahead and copy this down right now because I have to cut my screen off. January, 9.47 hours. February is 10.47 hours. March is 11.68. April is 13.07. So this is for number 16. Copy it down because I'm going to cut my screen off here in a minute. But that way you don't actually have to figure out the number of hours of daylight, because that takes you like 20 minutes to do before you can even do any of the real trick problems. Also, I'm going to warn you about the answers in the back of the book. They're wrong for what I'm wanting you to do anyway, because especially on the regression, some of them are fine, but on the ones where you have to do a regression, the book did not use the calculator to do a regression. The book used the numbers to find something that fits it. I just want you to do the regression with the calculator, because the calculator can get a more statistically accurate answer than we could ever do by hand. That means like your A, B, C, D, all those will be off from what the back of the book says for the regression problems. So don't worry too much about those, or the answers